Hi there, this is Mr. Coolis. It's really good to see you guys, even though I can't. This is weird for me. I'm an old fogey. I don't I don't do InstaFace, Snap a tweet, Snap a chat, whatever. This is not me, but I'm gonna do my best to connect with you. Please know that the teachers here are very concerned about you. We love you dearly, and we're going to do our best job that we can to connect with you over this time. It'll be trying for all, but I think we can make it work. I'm going to get going with math like I always do. If it's a 45-minute day, we're going to get 45 minutes of math. So as I go through videos, the expectation would be that you have out Desmos, that you have out a calculator, that you pause the video where you need to. I'm going to go kind of fast through some of these videos because I want to keep them as short as possible. So what that means for you is there'll be times where you'll pause the video and do the type of thing that I ask. But we're going to do our best job with connecting and go from there. So over the last few days, we've been talking about conic sections, specifically ellipses, parabolas, and hyperbolas, and we're currently on hyperbolas. You should have out this note sheet right here. If you don't have this note sheet, I posted it online. It's in Module 10 on Canvas, so you can go to Module 10. You can download the note sheet, and the information on the board right behind me is what we've been working on with that hyperbola information. So if you haven't been here, you can kind of look and see the formation of the equations and some of the pieces that are involved. It is a lot of information. So do your best to get it down, and I'm going to go over on the board. I'm going to take you over, and we're going to do a problem. The problem is it gives you vertices at 2 plus or minus 3. It gives you two asymptotes, and the question is, can you write the equation of the conic section in standard form? And I'm going to go through a problem on how to do that. So join me. Let's get this going here. All right, just like before, what I'm going to do is I'm going to do it from a picture drawing standpoint. So the information that I have here, I'm going to put on my picture. You can draw a picture of this also, and you can really do your notes on your iPads, or I mean, a pencil and paper would be great right now. If you have your device open and you're doing it on pencil paper, or some of you maybe want to open up two devices. Maybe you have the YouTube video playing on one device and then you have your notes on another device. I'm going to leave that kind of up to you, but here we go. So vertices are at 2 plus or minus 3. That's right 2, and then up 3 and down 3. And just by putting the vertices right there, we know how the hyperbola is going to sit. It's going to be a up-down facing parabola, or a hyperbola here, and then another branch up here. The two pieces of the hyperbola are called branches. So I know those vertices, and what we did last week is we drew in what was called a reference rectangle. And really what the reference rectangle does is it's a rectangle that allows you to draw in the asymptotes, and then you just kind of take the branches of the hyperbola and snuggle them up to those asymptotes. So the fact that these two vertices are here tells me my reference rectangle is going to sit somewhere in like this. I don't exactly know how wide, but I do know they're there, and halfway in between the vertices is the center. So I know that's the center right now, and I can start with the basic form of my equation. An up-down facing hyperbola, it's going to be this equation right here, which I'm going to copy down off the note sheet. It's going to be y minus k squared over a squared minus x minus h squared over b squared equals 1. And I can plug in the h and the k, because the h and the k values are that centered value, so it's 2 comma 0. So what I can do right now is I can plug the 0 in for the k, and I can plug the 2 in for the h. It becomes y minus 0 squared over some a squared value, which we don't quite know yet, minus x minus h squared, so it's x minus the h value is 2 squared over some b squared value, which I don't quite know yet either, equals 1. And if I can plug in those two values right there, I'll have the equation of what I'm looking for. So center, asymptotes, negative 3x plus 6 and 3x minus 6. Well, negative 3x plus 6, if I was up 6, 1, 2, 3, 4, 5, 6, and I went down 3, 1, 2, 3, and over 1, and 1, 2, 3 over 1, I'm going to notice that that asymptote goes right through the center. And all the asymptotes will go through the center. That's a property of the hyperbolas. So I know I don't even really need these two values because I know the asymptotes are going to go through the center. So what I can do is I can just use the slope values on both of these lines, and I can draw the equation, or I can draw the asymptotes in there. So I know one of the asymptotes is down 3 over 1. So from here I go down 1, 2, 3 over 1, or up 1, 2, 3 and over 1. And I can dot in that asymptote there, and I'll dot it in down there. Let me erase that sloppiness. And I can do the same one with the other one. I can go up 3 and over 1. So from here it's up 1, 2, 3 and over 1. So my other asymptote kind of comes like this. And I got a pretty good idea right now of how that sits on the graph. The branches are going to come like this, but that's not really what I'm not concerned with. What I'm concerned with here, is, do I have the A and the B value? Now the A value is the value that goes from the center to a vertex point. So that value right there is 3. So I'm going to plug in for my A squared value, I'm going to plug in a 3. 3 squared is 9. So I'm going to put a 9 right down there. Then the other one is, what is the B value? And the B value is really how wide the reference rectangle is. And I don't have the reference rectangle, but I did notice for my two asymptotes, I went up 1, 2, 3 and over 1, and up 1, 2, 3 and over 1. And I have a good idea of what the reference rectangle looks like. And the distance from the center out to the side of that reference rectangle right there, that's 1. That's your B value. Fumble! So I plug in a 1, and 1 squared is 1. And I have a pretty good idea of what the graph looks like. It's going to come up like this. The branches, they're going to come down like this. And got a really good idea of what the picture looks like. And the basic form, they probably wouldn't even write the 0 in. You can if you want, but it's y squared over 9 minus x minus 2 squared over 1 equals 1. And what I want you to do right now, I want you to go to Desmos. Here's where you'd have your two devices open. I want you to go to Desmos. I want you to crank that into Desmos. And then I also want you to put these two asymptotes in. And when you do that, you should get this picture. So it's a great checking tool to see if you were right or wrong.